Next up, we're going to welcome Marek from Celo to talk about scaling for blockchain applications.
Thank you. Thank you. Hey everyone, it is really wonderful to be here today, a real pleasure. My name is Marek Olszewski. For those of you who don't know me, I'm one of the co-founders of Celo. It's an honor being here. I talked to my dad this morning, and I told him, I'm going to be on Stanford campus giving a talk, and he said, shut up, I'm currently checking out a new application called FriendTech. Haseeb mentioned it so many times earlier, I just felt I had to mention it one more time. Today we're going to be talking about Celo's L2 proposal and what we're doing to kind of scale blockchains for real-world adoption. Earlier this year, I gave myself a goal to try to create slides exclusively using emojis. So if you like the format of this talk, let me know later. You can find me on Twitter at Marek_. And so I wanted to start with an interactive question, and actually I think Haseeb also posed a similar question. I'm kind of curious how many people here really use Web3 products on a regular basis, either them or they know friends. I see maybe 20% of hands going up. That's pretty good. That's better than I've seen in other conferences. But it's still not anywhere near close enough to 100%. And it certainly, I would say, would make Vitalik sad, shown here in the form of a cat emoji, of course, because there's no emoji for Vitalik. And it's a real shame because I think many of us here are working really, really hard to create kind of the following future, right? We want the future of Web3 to look like a Best Buy on Black Friday, right? We want people to be rushing into the house of Web3, really eager to get in. But sadly, the reality is, closer to a Bed Bath & Beyond, a sad, empty Bed Bath & Beyond, where just the people who raised their hands earlier are kind of running around having all the fun. And, at Celo, we're working really, really hard to create a platform that can change this. And specifically, one thing that we've been doing that maybe you've seen kind of in crypto news recently is, we announced recently that we're, initially we proposed, but now we're kind of announcing that we're transitioning Celo into an L2. And so for this talk, I wanted to spend the majority of the talk talking about kind of the design of the L2 and what we're doing that we think is unique and really interesting in the L2 space. And also, how do you think about transitioning an actual L1 into an L2? But before we do that, I thought it'd be nice to just spend a minute just to give you guys a super quick overview of Celo. If you've heard of Celo but don't know, the details, or if you've never heard of Celo, this might be interesting. I think first and foremost, Celo is a EVM-compatible kind of proof-of-stake layer 1. We put a lot of work into making it be a really scalable consensus. We worked really hard to create a really scalable consensus protocol. And of course, we picked the EVM because Celo has origins in Ethereum. I mentioned that we're really excited about kind of building for this Best Buy moment. And for us, that means really building with ease of use and accessibility in mind. We're creating a platform that makes it easy for people to build products that are much easier to use than kind of traditional Web3 offerings. And the way we're doing that is, one, I think with a mobile focus. Celo has had its kind of roots in mobile. Some people refer to it as kind of a mobile-first blockchain. Certainly for accessibility, there's now 7 billion smartphones in the world. I think it's really, really important to be able to build products that are able to run really well on these smartphones. And then the other thing that I think is particularly interesting is, and that's been really well received, is the ability to pay for gas with tokens. So in Celo, you can pay for gas with a stable coin, and you can send it to someone, and that person can then send it on to another person without having to go and figure out, how to buy a volatile asset to pay for gas. This has been something that's come up a lot lately with account abstraction. A lot of people are excited about this in the context of account abstraction. Nice thing about Celo is that you can do this natively today using EOA addresses as well. And then the final thing that I think some people really appreciate about Celo, Celo launched with full on-chain governance 3 years ago. And one of the first governance proposals was actually to make it carbon negative, to have the protocol programmatically buy carbon offset credits using block rewards. And the proposal passed, and for the last 3 years, the protocol has been buying these credits, offsetting the kind of estimated emissions that it's contributing to. And I think because of that, a lot of refi projects have come to Celo, and some people kind of think of Celo as kind of the home of refi. I think this focus on ease of use and accessibility, which ultimately has kind of translated into a lot of real-world use cases, a lot of people building products on Celo that are anchored in kind of real-world users' needs, has resulted in a lot of growth over the last 6 months. Even though it's a down market, a lot of these real-world use cases are particularly still important for people, and so there's been a lot of active addresses that have been kind of joining the ecosystem over the last 6 months. So that's been really exciting to see. And then of the chains that Nansen tracks, there's also been, you can actually see this very clearly as you kind of compare it to the other chains. When it comes to active address changes in the last month or even in the last 6 months, we kind of rank #1 on Nansen. So that's the quick intro. But as promised, I wanted to kind of spend most of this talk focused on kind of the L2 design and architecture. And kind of in that context, I think it's interesting to think about the constraints and kind of the goals that we were faced when thinking about this, I would say, pretty audacious kind of proposal to turn kind of an L1 that is decentralized, that is running into something that kind of rolls up to Ethereum. And I would say there were maybe 2 really important goals. The first goal was maintaining the cheap gas fees. So one of the nice things about having a really scalable proof-of-stake consensus protocol is that you can create big blocks and you can keep gas fees low. And that's attracted a lot of these use cases that I mentioned before, ones that are focused on mobile, ones that are focused on kind of payments and ease of use. Things like payment use cases, community currencies, micro-lending, universal basic income. There's a lot of projects of that nature on Celo. And if we were to start, if with this transition, we were to raise gas fees to the order of where they are today for Arbitrum and Optimism, then those use cases would probably not be able to survive on Celo. And so this was a pretty hard requirement for us. And luckily, if you look at where the cost of data availability goes, where the cost of transactions on L2 goes, the majority of that cost goes towards data availability. So we're talking about 90 to 95% of the cost of a kind of Arbitrum or Optimism transaction ends up going towards paying to have that transaction be stored on Ethereum. And so luckily, there are some alternatives. And the one that we ended up landing on in the proposal is EigenLayer. Sriram spoke earlier today, but if you are not familiar with EigenLayer, it's effectively a really nice marketplace of trust that allows any Ethereum kind of validator to effectively restake their ETH that they're currently staking in order to validate, and basically use the trust that comes with staking that ETH and apply it to other types of services. And luckily, there's a lot of validators in the Ethereum ecosystem, so there's a lot of trust. And so this is a pretty compelling place for us to look for a source of cheap data availability. And of course, EigenLayer is working on EigenDA, which is in effect their version of dank sharding that they're kind of bringing to market potentially years before it comes to Ethereum. So pretty exciting, and I think critically it's also run by, importantly it's run by Ethereum validators, and so from an ecosystem alignment perspective, it's pretty compelling. So that's how we kind of thought about goal number one. Goal number two was one around decentralization. As a layer one, we obviously spent a lot of work cultivating a community of folks who were interested in kind of running the network and now are kind of independently running the Celo network. And so we have a really good level of decentralization that would be a real shame to kind of just throw out the window and kind of move towards a just centralized single sequencer. It just felt like it would be a real step backwards. And so to mitigate or to address this challenge, we worked really hard to think about how we could transition this decentralized validator set into a decentralized sequencer set. In a traditional L2, sequencing is something that is certainly a censorship target. And so by having a decentralized sequencer as well, we get to have a nice cherry on top where we can have a much more censorship-resistant network. And I think critically too, it allows us to kind of contribute to the overall ecosystem and kind of create this public good that others can use as well. And kind of the third goal, and maybe for those of you kind of really paying attention, you might have noticed that this doesn't really look like the number 3, but it's the best emoji for 3 that I had. But I think more importantly, I said there were 2 goals that we wanted to kind of focus on. And you're right, but as is very common when you're thinking about a problem really deeply and you're kind of investigating, you end up kind of realizing that there's more things that you didn't think of before. And for us, that was kind of this third, I would say, constraint, which created this third goal, which was we wanted to maintain Celo's one-block finality. So Celo is, I think, relatively unique in the EVM space in that it offers token economic guarantees that incentivize basically the creation of, strongly incentivizes the creation of blocks that give you one-block finality. Similar to Cosmos, we have kind of slashing on equivocation, and that in effect results in really strong economic guarantees that end up having the blockchain create blocks with this one-block finality. And that's really useful for a lot of, I would say, use cases. If you're buying maybe a digital asset, on a chain, it's not that important whether or not the blockchain reorgs. Because if your transaction gets undone, then at least you're still left with one of the 2 assets that you were trading. But if you're buying something physical with something on a blockchain and the transaction reverts, suddenly you can't undo the physical transaction. And so you might be in a situation where you might have given some item to someone and they now also have the money that they should have paid you. And so one-block finality is really important for a lot of use cases. And so we worked really hard to offer it in Celo, but it's quite challenging to offer it in a L2. And the reason for that is because there are 2 sources of potential reorgs that can happen. One is around sequencer and batcher equivocation. So a sequencer and/or a batcher might be able to kind of tell you one thing, that they're guaranteeing that your transaction will be part of the next block, but then they can choose not to actually include it in the block that they upload to the L1. And one way we can address this is by adding slashing, which again is not too difficult to do in our case because we already have slashing for equivocation in the L1. And then the other thing that we can do is if you're bridging assets from the L1 to the L2, or if you're injecting forced transactions, There's reorgs that can happen on the L1 as well. Of course, Ethereum can reorg. And so our solution there is just to wait the kind of 12-ish minutes before sending these transactions over to the L2 to guarantee that they get finalized with the finale gadget on Ethereum. So how does all of this look like together? It starts to look a little bit like this. So I wanted to kind of walk you through the life cycle of a block on this design. On the left, we have our decentralized sequencers. In the middle, we have the kind of EigenDA middleware and all of the actors running it. And on the right, we have the L2 full nodes. And of course, Ethereum, the chain, is on the bottom. And so the life cycle starts with a transaction bundle that a leader in this BFT-based consensus protocol decides to propose to the network. And then, just like with any BFT-based consensus, this transaction bundle is gossiped around. And then with BFT-based consensus, basically 2/3 of these sequencers have to sign off on this state transition. And by doing so, they'll sign the bundle. And then the leader can aggregate all of these signatures into a single BLS multisig. This is what we do today in the L1. We use BLS 12377, and then we aggregate all of the signatures into a multisig with a bit vector, so you have accountability. And once you have this, then you know that the decentralized sequencers have agreed on the following state transition. And so the next step is to upload this data to EigenDA. EigenDA will upload this data to divide it up and upload it to all of its nodes in a bandwidth efficient manner. That's what makes this particularly cheap, is the fact that data availability is actually a embarrassingly parallel problem. And this is why Ethereum is looking at kind of launching dank sharding in the long term, because it's just much more bandwidth efficient than using a consensus protocol for data availability. And so EigenDA then distributes this and offers a EigenDA certificate back, which you can think of also as a multi-signature. And then once you have this certificate, then the leader in this protocol can simply upload it to Ethereum and have it kind of live on chain, so that the transaction bundles can be ordered by the L1. So now any full node interested in syncing with the chain can just download this certificate from Ethereum. It can then go to EigenDA, fetch the data from EigenDA. It can fetch the transaction bundle. It can fetch the BLS multi-signature and the bit vector. And then critically, it can verify this data. So each full node knows what the current decentralized sequencer set is at any point in time. There's a proof of stake consensus protocol that governs and effectively elects these decentralized sequencers, and this full node knows which of these sequencers are in the set and which are not at any given point in time. And so it's actually possible for this full node to verify the authenticity of those signatures and make sure that 2/3 of the sequencers signed off on this particular transaction bundle. And of course, the way to do that is to take the bit vector, look at the public keys of all of these decentralized sequencers, aggregate those into a single aggregated public key, and then you can verify the multi-signature. And then, the full node has the transactions. It can execute them. It can derive the state root. It can, in effect, sync for that block. And I think this is a really interesting design because I think if you look at today's L2s that have a centralized sequencer, frequently the check to see whether or not the transaction bundle is valid, happens simply on Ethereum, because it's cheap to verify a signal signature on Ethereum, and so only a certain blessed address can write to Ethereum at a certain address, And so everyone knows that, if you're reading from the address, the call data from the address, well, then in fact, that transaction bundle was in fact kind of signed off by the sequencer. But if you're going to do this for a decentralized sequencer, suddenly the gas costs are going to start growing with the number of actual sequencers that you have. And so one nice trick is you just offload that to the actual full nodes. They can do the check themselves, which I think ultimately is a much cleaner design. Now, if you look at OPStack, they do something really, really nice. They gossip these unsafe blocks in the meantime, right? Waiting for these blocks to go through Ethereum can take time. Everyone wants snappy applications. And so one way to do that is to have the concept of an unsafe block and have that be gossiped on a second P2P network for the L2. And that's really nice. And then you can have these unsafe blocks so that you can kind of promote the safe blocks when you see the same data come in through the L2. But that sadly creates the possibility of equivocation. And so it's potentially possible that if you do that, you might start running into kind of one block finality issues. It would be preferable if those unsafe blocks were always kind of guaranteed in some way with some kind of economic guarantee to reflect the ones that are going to go to Ethereum. And so the way to do that is, each full node can just check to see that these two things match at every given block height, make sure that the transaction bundle from the P2P network matches what it's seeing on the L1. And if they don't match, then that's really easy to prove. And you can effectively slash 2/3 of the sequencers that signed both of those two transaction bundles at the same height. And if you do that, then you can use kind of Celo economic guarantees that basically incentivize the sequencers not to do this because, of course, it's really easy to prove and they could get slashed and that would be, costly for them to do so. And, importantly, this is also not difficult for us to do because we already have all of the code for this because we're doing it already for ensuring one block finality at the L1 level today. Cool. So in summary, this design gives us low gas fees. I mentioned, 90 to 95% of L2 gas today goes towards data availability by using a significantly bandwidth cheaper design. We can dramatically cut that cost down to below 1 cent a transaction, which is kind of the ballpark for which our users on our platform are willing to pay. And I think also just a really nice side benefit by using EigenDA, it's still validators Ethereum validators, I should say, who are running the data availability network. And so that is quite nice. It kind of gives us lots of great trust. There's lots of Ethereum validators, and it's also really nicely aligned with Ethereum today. Secondly, we get to keep the same level of decentralization and, in fact, improve on that with this design, in large part thanks to us being able to reuse our production-ready BFT-based consensus protocol, which, the network launched 3 years ago and has been running in a way that's been rock solid with only one production incident. And, this would be one of the first decentralized sequencers to ship, so we're really excited about that. And it, of course, also gives us significantly more censorship resistance and just better uptime. And then finally, by having just this slightly slower native bridge experience, we can end up having this really nice improvement in UX where people can transact and just know with some economic security that their transactions cannot reorg. And then, of course, if you are sending a really big transaction, then you can just wait the 12 minutes and get the full Ethereum economic security. And so it's really nice for small transactions. People don't have to wait. For big ones, you can opt to wait a little bit longer. Either way, you have different levels of economic security that are preventing reorgs from happening. And one of the other nice things about this design is you can actually layer in additional kind of token economic incentives that give you even more economic security. So, we could, for example, add eigenlayer also to add slashing with eigenlayer to offer even more economic security for that one block finality. And I think critically, what does this mean? I think it just means that, Celo becomes a really nice platform for sure for people to build on top of, but it also becomes a nice place to build L3s on top of, because you can just take an off-the-shelf roll-up product and just be able to kind of deploy it on Celo and inherit kind of the one block finality, inherit the cheap gas fees, inherit all of the nice features that we're working so hard to provide. And I think most importantly, perhaps, the thing that gets me really excited is we're working really hard to do this in a way that will be fully seamless. And so the idea is to do a hard fork, multiple hard forks, actually, I should say, that will kind of upgrade Celo into this state, similar to how ETH hard forked and upgraded into ETH2. And so that's just really nice for developers because they can kind of get started today. If you're really excited about the Ethereum ecosystem, if you want to build on top of L2s, then you know that you can do that on Celo today, inherit all of the really great ease of use features, and then still get hard forked into an L2 in the future. So that's really everything. We just want to end with kind of a quick call out for Valora. If any of this sounded interesting, if you were kind of curious to learn more about what you can build on top of Celo, what these easy to use applications really look like, then definitely check out Valora. You can go to valora.xyz. It's a really easy to use mobile wallet that is a signing wallet. You can use dApps with it. You can sign transactions with third-party applications. But I think more interestingly, it also is a really nice wallet for sending P2P payments to people in your contact list. So I mentioned that Celo has this kind of real focus on ease of use and mobile early on. One of those, Valora does a really good job of using these platform features, including kind of the feature that lets you send value to phone numbers, and including the feature, of course, that lets you send value and pay for that transaction fee in kind of the thing that you're sending. So if you're curious and you want to check that out, definitely take a look. And there was an interesting conversation earlier around kind of whether or not folks should build platforms or end user applications. We've heard a lot of similar comments coming from people who are building dApps. Many people want to get closer to their end users. People who are building web apps, decentralized web apps, want to get closer to their users, and they want to have better integrations with wallets. And that's one nice thing that Valora is now offering, is this ability to send push notifications to your users through the wallet, and then have people perform some action with your dApp with just one tap. And so if that's like an interesting feature, then definitely, for you as a builder, then definitely check out Valora because I think it's pretty neat. So that's it. Yeah, thank you so much. It was a real pleasure.